All right, so we're in journal 28 here, and I'm going to start us off with a problem where we're just simplifying expressions. So like this first one here, we're adding both of these parentheses together, so you want to combine like terms. Like x squared with x squares are considered like terms, so you can add the coefficients together. So let me grab my highlighter here, get this set up. So I was saying like x squares can be combined because they're both the same exponent. So if I combine those two, I would have to add the coefficients. So 2 plus 5 gives me 7x squared. And then I could add the x to the first powers together. So positive 3x added with negative 1x gives me positive 2x. And then I have a negative 6 added with a positive 4, which gives me a negative 2. And so when I take a look at what I've already combined, I can't combine anymore because that's an x squared, that's an x, and that's a constant. We can't combine those types of numbers. So this is it. This is my final solution. Or not solution, but my final answer. So in this part here, we have an x that's outside this parentheses. So if it's outside the parentheses, we need to distribute this inside because we're multiplying here. So if I were to distribute, I have x times x squared. Now remember, this x is to the first power. So when we're multiplying x's together, we add the exponent. So 1 plus 2 gives me x to the third power. X times negative 1, well, that's just going to be negative 1x or negative x. And then when I take a look at these two, I can't combine because that's x to the third power and that's x to the first power. And so this is it. This is my final answer. All right, so like the objective here is just to combine like terms depending on their operation. So adding, subtracting, dividing, and multiplying. So let's take a look at what we are working with here today. So I've taught about this point, we've talked about trinomials. So trinomials is when you have 3 terms in an expression. We have binomials. So binomials are when you have 2 terms in an expression. And then monomials is when you have, I think I spelled nomial wrong. Nomials are when you have 1 term in an expression. And so in this case here, we're going to talk about, okay, what do you have when you pass 3 terms? So after you pass 3 terms, we just call them polynomials. Polynomials is talking about many terms, poly meaning many, nomial meaning terms. And so let's talk about polynomials today. So polynomials are expressions with many terms. Polynomials can have variables, meaning those x's or letters, symbols used to represent unknown numbers. Exponents, meaning those subscripts, not subscripts, superscripts. So those tiny numbers that sit above a variable or a constant. And constants are just standalone numbers like this negative 1 here. So in this case, I have a trinomial here, but if I were to add more terms, they would turn into a polynomial. We're going to talk about 2 very important definitions here. It's called the degree of function and leading coefficient. I'm going to be using these terms later on when we get into graphing, so this is really important that we understand what they mean for that graphing process. So degree of function is talking about the highest degree in the function. So the highest degree here is the second power. So this is a second order function or second degree. The degree of the function is 2 or the second. So the highest degree here, or the degree of the function here, is 2. So if I were to ask you, what is the degree of the function? You would say 2, or the second. The leading coefficient here is the number in front of the variable with the highest degree. So x squared is the highest degree, right? But the leading coefficient is the 4. So if I were to ask you guys, what is the leading coefficient? You would say that it's 4 because it's in front of the highest power. All right, and so that's it for the journal today. In the next slide, I'm going to be doing problems from the packet 6 on page 2. So if you need help with page 2 of packet 6, I would keep on watching. So here I have a problem that's number 4, and you're subtracting these two parentheses. So whenever we're subtracting, parentheses, we actually want to distribute this exponent first into the parentheses. So like in this case, there's a minus sign in front, whereas this one here doesn't have anything in front of the parentheses. So this parentheses gets brought down without the parentheses needed. So negative 18x squared comes down, plus 4x comes down, and negative 16 comes down. It's just because there's nothing here in front to multiply in, so I can just bring it down the way it is. This one here, I am going to distribute the negative sign, so I'll have a negative 15x squared, a negative 4x, and then a negative times a negative 13 makes a positive 13. So then I'm going to combine like terms here. So the x squares will combine. That's a negative 18x squared added with a negative 15x squared, which gives me negative 33x squared, looks like. So remember, we don't combine the exponents. We just combine the coefficients. And then we have a 4x and a negative 4x. So it looks like those will actually cancel. So that's kind of nice. And then I have a negative 16 here and a positive 13, which will add to make a, that would make a negative 3. So in this case, we have negative 33x squared minus 3, and that's our final answer, because these two do not combine because they're different exponents. All right, so in the next one here, I have an x squared, negative x squared, and an x plus 5. So I do need to distribute this inside. And when we distribute, we're going to have to add the exponents, right? That's a square, that's the first power. So we have x to the third power, but then I have this negative in front of this x, so negative times positive 1 is just negative. And then I'm going to need to multiply this to the 5, so that's going to be negative 5x squared. And then I can't combine these two, so this is it. I have to leave it like this. Okay, sorry if it looks really messy here. Yours should be a lot neater because you have more room to write. All right, for part 6 here, number 6, I have a 3x on the outside of the parentheses, so I do need to distribute that. So be very careful when you distribute. I like to distribute by combining the numbers with the numbers first. So like this 3 is going to be multiplied to a negative 1, so this is technically negative 3. But then this x is to the first power and this x is to the second power, so that's x to the third power when they multiply. So numbers with numbers, x's with x's. 3 times 2 gives me a positive 6. X times x gives me x squared. And then last but not least, we have 3 times negative 12 gives me a negative 36. But there's an x here, so I have 36x. And these are not like terms because they're all different exponents, so this is my final answer. Last but not least, I have two parentheses here with two things outside. So first off, I'm going to need to distribute the stuff that's outside the parentheses. So like I need to distribute this 2x in, and also this negative 5 into the second parentheses. So if I were to distribute this 2x first, that's 2x times x, which is 2x squared. And then 2x times negative 1 gives me negative 2x. And then the next one here, I have a negative 5 times of x gives me negative 5x. And then a negative 5 times a 3 gives me a negative 15. So I notice that the inner terms combine because they're both x to the first power. So then I have 2x squared that comes down. The inner terms combine to give you negative 7x. Remember, don't combine the exponents. And then the negative 15 comes down as it is. And so I can't combine anymore because the exponents are all different. So this is my final answer. All right, and that's it for this video. I hope that was helpful.